About 100 years ago, the American poet Robert Frost wrote The Star Splitter, which was all about the purchase of a telescope by somebody from the town. Often he bid me, come and have a look. Up the brass barrel, velvet black inside, and a star quaking at the other end. That telescope was christened the Star Splitter because it didn't do a thing but take a star and split it into 2 or 3. So telescopes are star splitters, and of course they have powers. The first power you think of course, is magnification, but that's the third or least important power of a telescope. The most important power of a telescope is its ability to gather light. And the bigger the telescope, or the wider the telescope, the more light it can gather, and the better the image will be. There are 2 types of optical telescope that are typically purchased. The first is the refractor, or refracting telescope. This uses a lens to gather light from the object you're observing. The other is the reflector, or reflecting telescope, and this uses a mirror in place of that lens. The lens is typically at the top end of a refracting telescope. The mirror is usually at the base of a reflecting telescope. Now, refractors are typically sold in department stores, big box stores, or yard sales. Reflectors you typically have to go online to find, and I would say the reflector is a better buy for you. The mirror is going to be larger than the lens. Why is that? Because mirrors are cheaper to make than lenses, so that means you can get more aperture, more light gathering power with a reflector instead of a refractor. So this is a 6-inch Newtonian reflector. Newtonian, Sir Isaac Newton, back in the 17th century, made a good working model of a reflecting telescope. It's called a Newtonian for that reason. 6 inches is because the telescope has a mirror at the base, which is 6 inches in diameter. So it's a 6-inch Newtonian reflecting telescope. Now, the light path from the object you're observing goes through the tube, hits that mirror down at the bottom. The mirror is slightly bowl-shaped or concave, which means the light bounces back out the tube again, but it's coming together to a focus at this point here. Behind this spider mount is another mirror, which is a flat mirror, set at a diagonal, which shoots the light out this hole here. And in that hole, you have placed an eyepiece. Now, this is your magnifying glass. This is what does the magnification. And that goes in there, back into the focus draw tube, and you can bring it in and out of focus just like that. This is also a reflecting telescope, but it's not Newtonian, it's Cassegrain. Laurent Cassegrain was a French priest and astronomer who, living at the same time as Newton, came up with a different design. You notice that the eyepiece is down here at the bottom of the telescope like a refractor, not like a reflector where it's way up here at the top. The light goes down through the tube, hits that mirror, comes back out again, hits the secondary mirror here, which is not aimed to the side, but straight back down through that hole in the middle of the mirror. Then it comes out the back end and comes into a focus right here. This is the focus now for this telescope. This is an 8-inch reflecting telescope. It's 8 inches in diameter. The nice thing about this is you don't have to climb up onto a ladder to look through the eyepiece up here at the top. You look down at the bottom as you would with a refractor. Now, before you decide to buy a telescope, you need to ask yourself, what do you want the telescope to do for you? Do you want to do astrophotography? Do you want to just have a telescope that lets you point and look at things in the sky? Before you buy a big, expensive telescope, I would suggest a simpler route, and that is, of course, to consider getting just a nice pair of binoculars to look at the sky. Binoculars really are 2 small refracting telescopes mounted together to give you stereo views of the sky. They're less expensive than telescopes. A good pair will run you less than $100, and you can use them for looking at things not just on the Earth, but things in the sky too, like the Pleiades star cluster, or the Orion Nebula, or the Great Andromeda Galaxy. They give good views of those things. And like I say, you can use them for looking at things on the Earth as well, because they have prisms in them that put the images right side up. Telescopes typically don't have that. They have lenses that put things upside down and backwards, but when you look at things in outer space, it doesn't matter. Things on the ground, you want things to be right side up. Birds, trees, ships, and so on. Binoculars have things written on them that can tell you what they do. This pair has a legend on it, 7x35, which means that gives you 7 power. You can't change the magnification, it's a fixed 7 power. 35 refers to how wide these pieces of glass are in millimeters. So each of these lenses is 35 millimeters across. This is 7 by 35. This is the most common type of binocular you'll find out there. It lets things look to you as if they're 7 times closer or 7 times larger to the eye. You can get bigger telescopes that give more magnification. This is 7 by 50, same magnification, but why a larger aperture? 50 millimeter lenses, it gathers more light, the image becomes brighter and therefore sharper. Now, these are 15 by 60, 15 power, 60 millimeter eyepieces in the front. These are starting to get a little bit bigger and heavier. Then we get into something like this, which are 10 by 70. So again, 10 power, each piece of glass 70 millimeters across. Starting to get kind of hard to hold steady, particularly if you're up like that, and that's a problem. So when you get something like a pair of binoculars, the best thing you can do with them is to mount them to a camera tripod. So once you have the binoculars secured to the camera tripod, you can spin it around in azimuth, or compass direction, and up and down in altitude, and you treat them just like a regular pair of binoculars. It gives you a nice steady view, and if you see something interesting, you can hold it there for the next person to look and see what's up there in the skies. When you want to focus a pair of binoculars, you have to be aware that most of them have two focus settings. One here, in between the two lenses, and one up here on the right side that you look through. The way you do this is you close your right eye and you hold these up with just your left eye open, and then you do the coarse adjustment with the left eye, like so. And when you bring that into focus on outer space or whatever you're looking at, then you close your left eye, open your right eye, and focus with the right eyepiece here. And that brings things into perfect focus for your particular vision. Very nice. Telescopes are wonderful tools that allow us to peer into the universe to discover the wonderful things that are out there. Wisely purchased and carefully, properly maintained, a telescope will provide you with astronomical dividends in the years to come.